Hello everyone, and welcome to the Brite Computers webinar. Today's topic, Brite Scalable Wireless Solutions. Let's get started. Our speakers today are Trevor Smith, Vice President of Sales for Brite Computers, and Perry Correll, Director of Product Marketing, XIRRUS Wi-Fi Networks. Trevor, the audience is yours.
Thank you, Matt, and good afternoon, everyone. This is Trevor Smith, Vice President of Sales at Brite Computers. With the explosion of mobile devices and the capabilities of what users can do and really demand to do on their phones, tablets, and as well as traditional laptops, we're very excited to present to you today on the trends in wireless networking and how our partner XIRRUS is really solving those issues. What I'd like to do is start off with a quick introduction to Brite Computers for those of you who don't know us or don't do business with us today. And then I'll flip it over to Perry to give an introduction to some of the market issues and trends, and then discuss some of the scalability capabilities from XIRRUS. At the end, we'll have a question and answer session, so feel free to post your questions, and we'll make sure that we try and get to them. So as a quick introduction to Brite, we've been in business almost for 30 years now. We're very excited about that anniversary coming up next year. We've expanded our locations, where our headquarters is still up in Rochester, New York, and we have now 4 additional locations throughout the U.S. Historically, we've specialized in the manufacturing, servicing, and supporting of custom configured computing, which has really given us a heritage towards customer support and making sure that we support our customers not only in identifying the requirements, but also through the life cycle of the product, and especially when issues come up. We've been experiencing exponential growth over the last 7 years in multiple different areas, especially in the areas of security, virtualization, and the requirements of infrastructure to support both security and virtualization. Throughout the last number of years, we've also built a number of specialty solutions in a variety of vertical markets, including commercial, small to medium business, with our managed services solutions, healthcare, education, and even state and local government. Since our inception, we've been ISO 9001, we've been ISO certified. The current certification, which is continuously gone through every 9 months, is the 9001-2008 certification. For those of you not familiar with it, it really regulates us in our policies, procedures, and ensures quality product is delivered, whether we're making it or we're delivering it to our customers from a vendor. In addition, we've contracted an ITIL Foundations version 2 certification with some of our individual service providers and engineers. For Brite, we kind of break down our capabilities into 3 main areas. Today, we're going to talk about one of the areas within computing infrastructure, the wireless networking side. That computing infrastructure also includes our desktops, laptops, servers, storage, with key partners like XIRRUS, IBM, Lenovo, Fujitsu, and others. The second area is our security practice, where we focus on our customers' data, whether it's on the network or the endpoint, and we've developed strong relationships with partners such as McAfee, Checkpoint, and even some point solutions like document rights management solutions, which next month we'll have our seminar on document rights management. And the last area is our services. Services can be detailed out to specific products, like the support, evaluation, and deployment of a product like XIRRUS. It can also be project-based support, upgrading of Exchange and servers, and even complete outsourced and managed services that we provide to our customers on an hourly or monthly basis. So that's a quick introduction to Brite Computers, and that'll lead us into the next stage, which is our first polling question, to help us understand a little bit about how you're using tablets and mobile devices in your environments.
And that does bring us to our first polling question of the day. So the results of the poll are how are tablets used or mobile devices used in your environment. Looks about 50% of individuals use personally purchased tablets. 25% were small teams are using it. And 25% have deployed tablets to specific groups. So I've got the poll finished here today. I'm going to go ahead and transition it now to Perry, and he'll be finishing the presentation here. All right, Perry, the audience is yours.
Okay, thank you very much, Matt. I appreciate it. And that was an interesting poll. From what we've typically seen, that there's most studies have shown about 80% of businesses right now are allowing some type of personally owned devices, and obviously some businesses are actually buying tablets. And that's really what we're going to talk about today. We're going to talk about the scalable wireless solution. The whole idea is that the enterprise is changing significantly because of the influx of tablets. And kind of the easiest way to see that is kind of look at this first graphic. And you know, one of the things that's very interesting is on Christmas Day last year in the United States, over 7 million smart devices were activated, whether these were tablets, whether these are smartphones, or whatever they happen to be. And just some of these numbers, iOS devices and Android devices, and this is what's being done daily. And to be honest with you, these numbers are actually 4 to 5 weeks old, so they're growing exponentially, and it's kind of unbelievable to see that. Okay, I think we had a little hiccup there. All right, so what's happening, though, is that more and more devices are showing up, and they're going to end up on your network. Obviously, BYOD is a big point right now. Some people are for it, some people are against it. There's issues associated with it. But the whole problem is that with an estimated over 7 billion devices out there within a couple of years, these devices will show up. And they're even showing up in ways like point-of-sales devices. And you've got businesses that are looking at buying, you know, low-end handhelds just to eliminate printing costs. And as devices get cheaper and cheaper and cheaper, obviously it becomes more and more important to be able to support these devices, because it's not just a matter of supporting Wi-Fi. It's not that, you know, all Wi-Fi devices are the same. It's an issue whereas before I had 100 people on Wi-Fi. Now I've got 200, 300, 400 devices on Wi-Fi because people are carrying more than one device at a time. It's very, very important for everybody to understand that. And this is kind of a good graphic that you can look at, is that you know, based on a recent Gartner study, that within the next couple of years, 80% of newly installed networks are going to be obsolete because of proper planning. And what that all has to do is these are networks that not are in existence already, but these are networks that are being installed right now. And as a result of many individuals are still planning based on a coverage model. They're not planning based on a deployment model. And so it gives us some idea of what's actually happening out there and what are the challenges that we have to prepare for. And I think now we're actually going to do another polling question.
Yep, that brings us to our second polling question of the day. So if you could secure data on your tablets and manage those devices, would you adopt a tablet strategy? And the audience was 33% was yes, and about 67% said maybe, so nobody said no.
Okay, that's good to hear. Okay, so one very important thing to understand as we go forward is it's very, very critical to understand the tablet itself. And what I mean by that is the tablet is not a standard Wi-Fi device. And once again, I'm not picking on any vendor. I'm not saying there's any you know, shortcomings as far as their manufacturing. But if you have an environment right now, and let's just say you have 100 laptops and everything works great Wi-Fi service, performance is perfect, and I designed to replace those 100 laptops with 100 tablets, no matter the manufacturer, no matter if you get the best one, you're going to get a totally different level of service. And it's very, very key to understand that, because tablets by definition are consumer-grade products. They're not designed as a, quote, enterprise-class products that gives you different capabilities. I can have a laptop right now, and I can connect at 11N, and I can get 300 megabits worth of throughput. I can get 450 megabits worth of throughput. I'm getting nowhere near that with a tablet, and obviously even less if I'm doing a smartphone. And it's important to understand the difference between the classes of products. One of the most things to understand is that a tablet, because of its physical size, because of its design, it's going to have less capabilities. One of those less capabilities is obviously it's going to have a smaller battery. And so as a result, it's actually going to have a weaker transmit power capabilities. So whereas a laptop sitting on a table will connect at a certain data rate to an access point, a tablet sitting right next to it will typically connect at a much lower rate just because of the transmit capabilities of that device. At the same time, most of your laptops, the antenna design are built into the screen. So I have a very decent sized antenna, and I can transmit and I can receive. Basically, the gain of that antenna also gives me much, much greater signal. Obviously, a tablet is much smaller, and a smartphone is even smaller than that. so you'll have a typically much weaker signal. And this is the things to understand, and there's several of them across the line. So obviously, I have much less transmit power. I have less antenna gain associated with it. Tablets tend to have difficulty roaming. Once they connect to an access device, they tend to hold on to that access device instead of roaming like a laptop will to the next device, to the next device, to the next device. So you have to have mechanisms in place in your infrastructure to enable this functionality. Another thing to understand is that the new generation tablets will support more 5 gigahertz capabilities, and I'll talk a little bit more about that later, than the old tablets that only supported 2.4. What this all rounds up to is to understand the difference between a tablet and a laptop. And the biggest thing you need to understand is in order to support the same level of service, in order to support the same signal levels, you're never going to get the same throughput levels, but at least to get the same signal levels, you have to design a much stronger RF environment than you would for a laptop. Don't want to get down into the nitty-gritty here about RF, but typically if I'm designing a network to support laptops, I'll design it to what's called a -72 RSSI value. That's your signal strength, your received signal strength indicator. If I need to design it for a tablet or a smartphone environment, I have to design it for about -65. That -65 is 2 to 3 times a stronger signal than a -72. So it's very, very important to understand this. The fact that I have a very good, very functional, very high-performance wireless network today for my laptops, and I'm going to start adding tablets, that environment is going to change, and you really have to be ready for it. Another thing to understand, and it's also very, very important, is that all devices are different. If I've got an environment, and I'm always going to have a mix of classes of devices. I got multiple different types of laptops. They have different types of Wi-Fi capabilities. I might have different tablets. They have different wireless capabilities. And I might have smartphones. So as you can see in this environment, even though these devices are similar distances away from the access device, they're all going to connect at different data rates. That's Wi-Fi. That's how it works by design. Why this is important is in the upper left-hand corner there, I might have a laptop connected at 300 megabits per second. On that exact same radio, I've got a smartphone connected at maybe 6 megabits per second. And they're sharing that radio. So even though when the laptop's connected, he's talking at 300 megabits, and when the smartphone's connected, it's talking at 6 megabits, the problem is it's an aggregate throughput. It takes that smartphone 50 times as long to send that exact same message as the laptop. And this is the thing you have to adjust for, and this is the thing you have to design your network for. It's nice to design that everybody's going to connect at the highest possible data rate. It's not going to happen. All devices are going to connect at different data rates. So once again, sitting in a room, I have a laptop, I have a tablet, and I have a smartphone. They're all connected to the exact same radio, the exact same distance away. They're going to have totally different capabilities, and the users are going to have totally different Wi-Fi experiences. This is just because of the way these devices are designed. Not good, it's not bad, it's just the way it is, and it's reality. You just have to understand and design your network for it. Once again, this is why it goes back to that statement from Gardner, that so many networks being designed today aren't being designed with this in mind. That being said, let's take a very short review about Wi-Fi and kind of where we are and where we're going and where we've come from. A lot of people don't realize that Wi-Fi is actually pretty mature if you think about it. The 802.11 standard itself was ratified back in 1997. So it's, we're talking about, 15 years old now at this time. And once again, that's a pretty mature technology in our industry. So it came about in 1997. It was only a couple of megabits worth of throughput. In 1999, the two primary standards or amendments, 802.11a and 802.11b, came along. 11b offered about 11 megabits, and it was operating in a 2.4 gigahertz band. And 11a offered 54 megabits, and it was operating in the 5 gigahertz band. Both these bands are unlicensed. Both these bands have been around for a long time. Wi-Fi just decided to leverage them. One technology leverages the 5 gig. Another technology leverages the 2.4. 2.4 has some limitations. The biggest limitation is it doesn't have as many channels available to it as the 5 gig does. This also tends to be more of a noisy environment because there's lots of other devices like cameras, like microwaves, like Bluetooth that operates in the same frequency, so obviously it adds a lot of noise onto the line. More noise reduces your overall throughput. 5 gigahertz, on the other hand, not as many devices competing with it at that level, so it's a little bit of a cleaner technology. However, in 1999, the majority of devices were operating in 2.4. Those chipsets were much, much cheaper, and nobody considered Wi-Fi to be a challenge to Ethernet, so the majority of purchases were in the 2.4 band, whether it was 11B in 1999 or a few years later, 11G in 2003. Well, that 11G was probably the primary technology for several years after that. 11A and 11G finally actually kind of, or 11A and 11G, finally kind of, 2005, 2006, 2007, became your primary technologies out there. Then came along 11N. 11N was really a starting point for Wi-Fi as we see it today. What Wi-Fi was lacking up to that point was performance. Even though 11A said it did 54 megabits per second, 11G said it 54 megabits per second, your actual usable throughput is always going to be about half that. So you got about 22, 23 meg worth of usable throughput. The whole goal of 11N was to put Wi-Fi on par with 100 megabit Ethernet. That's really what it's designed to do. Whatever the actual numbers were, that's what the goal was. So 11N came along, and initially it offered 150 megabits per second, then 300 megabits per second. Right now, many vendors, including ourselves, are offering 450 megabits per second 11N, and the standard itself was designed actually to go up to 600 megabits per second. We're probably not going to get there because, as you can see on the right, there's some new technologies coming along, 11AC and 11AD. 11AC is designed to go up to a gigabit per second, and that's really, you're going to start seeing more and more of that at the end of the year with pre-standard residential type solutions. It's going to be more the middle of next year before you start seeing this more as a common thing in the enterprise. And then there's also 11D, there's 11AD. I just kind of want to give you a heads up. There's going to be a lot of talk and there's going to be a lot of hype about that. But be aware with that technology, it's really operating in the 60 gigahertz range, so it isn't a pure upgrade to the regular Wi-Fi. It's going to have some unique applications and some unique value because it actually is designed to go as high as 5, 6, or 7 gigabits per second, so it obviously gives you a lot of capabilities. But because it's 60 gigahertz, it's not going to be a seamless upgrade, and also it's going to have less distance. The higher the frequency, the less that traffic will propagate. So 60 gigahertz won't be a replacement for the others. As you can see there also, the 2.4 spectrum kind of stops at 11N. The 11AC is all a 5 gigahertz spectrum, and definitely it's going to continue to grow in that direction. But this kind of shows where we are, and obviously Wi-Fi is going to continue to expand as we go forward over the years. The other thing to realize here is that the 2.4 and the 5 gigahertz, I mentioned before about the different technologies that are available and the different amount of channels. 2.4 only has 3 non-overlapping channels available in North America, and it's very, very important to understand that. If you look at the 2.4 spectrum in North America, you'll see channels 1 through channel 11. Internationally, they go higher. They go up to channel 13 or 14. But in North America, we only have channels 1 through 11. What's important to understand is these are the regular channels that are available in the 2.4. Wi-Fi doesn't exist within a single channel. A Wi-Fi channel actually takes up 4 standard 2.4 channels. And what I mean by that is if I've got an access point or if I got a device and it's connected on channel 6, channel 6 is only its center frequency. That Wi-Fi channel actually extends from channel 4 all the way up to channel 8, which is why most vendors say that if you're deploying in the 2.4 environment, you want to use channel 1, channel 6, and channel 11, because what that does is it separates those 3 channels enough that one isn't interfering or overlapping with the other. So you really only have 3 usable channels in North America. Once again, internationally, you could probably squeeze a 4th channel out there, but you only have 3 channels. If I try to use channel 1, 2, 3, 4 at the same time, which many people do, they're just going to end up interfering with each other. If you're doing it at home in the AP at your house, it doesn't really make a difference. But doing it in a production network, in a corporate environment, it's just going to end up adding more noise onto your network. The more noise, the lower your actual throughput. 5 gigahertz, the advantage here is there's 24 non-overlapping channels. So obviously, as we're going to more density, as we're going to more devices, if we need more capacity, you definitely want to leverage the advantage of more channels versus less. Obviously, 5 gigahertz offers up to 8 times the amount of channels available in 2.4. The one thing to understand here is there's nothing wrong with the 2.4 band. It's going to be used. It will continue to be used for a long, long time. Just understand that there's much more capacity available in the 5 gigahertz band. So get as many of your devices, get as many of your new tablets, your laptops operating in the 5 gig. That leaves the 3 bands available for the 2.4 for your older devices, for your printers, for your point-of-sales device, for some video cameras, which tend to operate only in the 2.4 band. Leverage them both, but be aware of the advantages of the 5 gigahertz band. Another thing to understand is how much capacity is actually available when I'm talking about 2.4 and I'm talking about 5. If you look at this, when I say 2.4, when I say 54 megabits per second, the first thing you need to understand is Wi-Fi by definition is a very overhead-intensive protocol, which means it's half duplex, there's a lot of noise, there's a lot of error correction, all the traffic or the unicast traffic has to be acknowledged. So just because you've got a connection and that connection says it's 150 megabits per second, that's 150 megabits per second on the wireless side. However, when that transitions over to the wired side, the best you're ever going to get is about half that. So if somebody says you got 150 megabits per second, in a purely pristine, perfect environment, you'll get about 75. In reality, you're probably going to get about 50 megabits of usable throughput, just because of Wi-Fi collisions, error, noise in the environment, the whole thing. So a 2.4 radio operating on about 150 megabits worth of throughput is going to give you about 50 megabits of usable throughput. 5 gigahertz, on the other hand, if it's operating at 300 megabits per second, you're doing bonding, what's called bonding in 11N, that's going to give you about 100 megabits of usable throughput. And really, that's what you need to think about, and that's what you need to design for if you want a high-performance environment. So taking that to the next step, Gartner recently did a study, and they said, if you're looking for a ballpark figure, something to start with designing your network is that how many people can I put on a radio? And that's a great question. How many people can I actually put on a radio? And the answer is it really depends. It depends on what you're trying to accomplish. If you're trying to get a wired-like experience, you've got to limit the number of users on there. If you're just trying to give people connectivity with no guaranteed level of service, let's say I'm going to put Wi-Fi out in a city park, and I'm not guaranteeing any level of service for anybody, I could put a couple hundred users on one radio without any problem, but that's not going to give you a good experience. So what Gartner recommends is figure out about 6 megabits per user. So looking at this diagram, what you got a total capacity of 50 or 150 megabits worth of throughput. If I divide that by 6 megabits per user, these are the numbers you're going to come up with. And once again, some people look at these and they tend to be very, very scary, that a 2.4 radio is only going to support 8 users, or a 5 gigahertz radio is only going to support 15 users. Understand these numbers have to do with a very, very reliable wired-like performance. The numbers could be 10 times higher than that and still allow connectivity. So it all depends on what the user expectations are, what the quality of service is. So if you're in a school environment, if you're in a classroom, 15 users on a radio is probably all you want to do. However, if you also have Wi-Fi in the cafeteria and you're offering, services for whatever reason, you could have 20, 30, 40, 50, 60 people on one radio. Once again, it's not going to be as a quality of experience, but it's probably maybe good enough. And then if you're going to put Wi-Fi in the ballpark, out there and give connectivity out there, maybe you can put 100 people on a radio. Once again, it depends on the expectations, the type of, the user expectations and the use cases for the device. Very, very important to understand that. And once again, because Wi-Fi is a shared media, it's very important to design this way. And that's the key point. Speaking of design, the next thing to really understand is designing for scalability. And this is a big problem we have, and this is one of the biggest problems or biggest concerns Gartner had, is that many, many people don't design for scalability, they design for coverage. So I've got a room right now, and let's just say I've got 25 people in it, and everybody's got 5 bars. Everybody's got a real strong signal. Now I put 200 people in that same room. Every one of them has a real strong signal. Everyone still has 5 bars. The problem is now they're all competing with each other for access to that one radio or those 2 radios. And that's what scalability is all about. It's not just how strong a signal you have. It really has to do with how many people are competing to that one band. What vendors have done up until this point, many people have done, and customers have done to this point, they've thrown APs at the problem. You know, if I've got a problem, they're complaining the Wi-Fi is not really good, okay, grab an AP out of the closet, plug it in. Is it any better? Well, it's a little bit better, but not, well, put another one out there, put another one out there. And what you end up is networks where people are just putting more and more APs trying to fix a problem, and they're actually just making the problem worse. I can't tell you how many environments I've gone in and I've looked at this and said, you know, you can improve your Wi-Fi experience dramatically just by turning half your radios off. That might be an extreme. Maybe by turning about a third of your radios off. Because what happens is that most of these APs have one 2.4 radio and one 5 gig radio, and it's fixed. And after I've added more than 3 2.4 radios, I have no more channels left to use. I can't reuse channel 1 3 different times. Only one device can operate on one channel at a time. So if I've got 2 radios, and they're both operating on channel 6, and they can hear each other, only one of those devices can talk at a time. It doesn't matter who's associated to which device. Wi-Fi is like a room full of courteous people. Anybody can talk at one time, but if somebody else is talking, I'm not going to talk. So once again, on the right side, if I have 5 radios in that environment, and 3 of them are all on the same channel, only one of those devices can talk at a time. You're not adding any more capacity. Very important to understand that. A better solution is really going to be more mirrored after a wired environment. You know, deploy devices, deploy a single device, but then add more capacity to that device. So if I've got a small room with, you know, a couple dozen people or whatever, I could put 2 radios in a device and put it out there. If I have more people in the room, I can put 4 radios in that same device. If I have even more, I could put up to 16 radios. So it's kind of like having a chassis solution that I can put as many blades in there as I want, but I'm not pulling brand new cable. I'm not adding more switch ports. I'm actually doing with the one device that actually has a lot more cabling, a lot more capacity to it. And a better design or a better way to look at it is like this, kind of round out what I just talked about. Most APs that people have purchased up to this point are 2 radio mix. So I've got 1 radio on 2.4, 1 radio on 5. So in this case, I got 2 APs. I got a 50-50 mix of radios. I've got a 50-50 mix of clients. Everything works fine. You've got an optimized environment. The problem comes is the clients don't form like that. Clients will change. They can change over hours. If it's a classroom, I've got classes coming and going with different devices. They could change over weeks, and they can change over years as more and more devices are going to 5 gig. So now on the left-hand side, I've got an environment where 75% of my users are using the 2.4 band because those are the devices they have. Yet with fixed design APs, I still have a 50-50 mix of radios. And maybe a year from now, on the right side, maybe 75% of my clients are now 5 gigahertz. I'm still limited to that 2 and 2 mix. So once again, it's a limitation that's always been here. That's the way Wi-Fi was designed. There's nothing wrong with that design. But what we have to do is we have to look at it a little bit different. And what you're looking at now in the next generation of devices, and obviously this is something that XIRRUS supports, is multi-state radios. So the whole idea is you purchase a device that has, let's just say there's 4 radios in it. And if I have a 50-50 mix of clients, I can set 2 of those radios up for 2.4, and I can set 2 of those radios up for 5 gig. But if I end up, once again, the next class period or the next day or the next year or whatever, I've got 75% 2.4 clients. I can set that device up now with 3 2.4 radios and 1 5 gig. Once again, it optimizes the client to radio mix. And the same thing at the other end, the next day, the next month, the next year. If now I've got 75% of my clients are operating the 5 gigahertz band, I will change with it. Once again, it's kind of like thinking in a wired environment. I went through that many, many years ago, that you had 10 megabit, 100 megabit, and gigabit clients. Right now, pretty much most of your Ethernet switch ports are either dual or tri-speed ports that if I plug in a 10 meg or 100 meg or a gigabit device, it'll automatically adjust to that. That's the way wireless is going. Once again, wireless, if you look at it, is typically following wired by about 10 years or so. So same thing. If I show up with a 2.4 client, I can support it. If I show up with more 5 gigahertz clients, I can support that also in that environment. So very important to understand that. The next thing, and what's very, very important, especially when you come to scalability, is the amount of devices that are hitting your network and the architecture of the network. Traditionally, when I first started in this business, the normal way was you would have a bunch of APs, you'd collapse them back into a single controller. That controller is able to manage all the devices and push out configurations and push out changes. And it's a much better solution. The controller tends to be more expensive. The APs tend to be, less intelligent and less expensive. That worked really, really good with 802.11a, b, and g until we got to about the 54 megabit point. When we jumped to 11n and we're at 150, 300, 450, and even growing amount of bandwidth per radio, basically there becomes a tremendous strain on a single controller to support that. When you have hundreds of APs and each one have 2 radios in it, trying to collapse all their traffic back to a single device, you have a huge choke point, especially if you're doing any type of encryption, and you also have a huge single point of failure. So what you're starting to see now is more and more intelligence is going out to the edge. Once again, we're just like a wired environment. If you've got a little bit of gray hair like me, you remember the days when we had dumb hubs and everything collapsed back into a controller. Very similar, into a router. Very similar to the AP controller type environment today. So what's happening now is more intelligence is going out to the edge. Obviously, with XIRRUS, we don't even have a controller at all. We put intelligence in each one of our devices. So our devices operate much more like a wired switch. Traffic comes in, I look at it, I tag it, forward, filter it, encrypt it, decrypt it, whatever I need to do with it, and then I send it along its way, just like a layer 2 or layer 3 wired switch would today. And if you look at it, most of the new APs from your traditional vendors out there are also starting to do that. They still have the controller, mind you, but they're putting more and more intelligence at the edge to allow those devices to make forwarding decisions instead of having to force everything to collapse back into a single controller. And if you think about it, that's the only way we can scale. Forget all the marketing type stuff. It really is it's a math question at this point. So, I can't keep running everything through a single device. So for scalability, once again, you definitely need more and more intelligence pushed out the edge. So you have distributed intelligence. So you have 10, 20, 30, 40, 50, 100 different devices processing the traffic instead of just one. And the next thing for designing for scalability and control, especially in a BYOD environment, is to understand the devices and set rules and policies on those devices. So you've got your infrastructure here. And basically you've got on the right side, you've got your standard infrastructure that you have for your wired environment. You've got your switching structure, you've got connections to the internet, and you've got connections to your internal resources. At some point, you've added a Wi-Fi infrastructure in there. Obviously, in here, it's got the XIRRUS wireless array, which has a lot of intelligence built into it. But then you're starting to add other functionalities. Basically, you tie in to the device and the user management. So whether it's mobile device management tools, whether it's a NAC or a AAA service like Radius, or your Active Directory service, or LDAP, or whatever it is, this is all your intelligence at the back end. Some of it's directly integrated with the wireless. Some is actually tied into your Windows operating system or what other functionality you have. And it's time to make all these work together. So now you're going to have an environment where you've got your typical enterprise devices. These are maybe the laptops or even whatever devices that are 100% approved to operate on the network. And based on who that user is and or what kind of device they have, they're allowed full access to whatever enterprise resources they need to connect to. However, with BYOD, individuals can bring their own devices. This is where it gets a little bit interesting. With their own devices, you can give them full access to everything if you want, but then you can also restrict it. Based on what kind of device they have, you can actually limit where they can go. And that could be because maybe the device they have, you're not sure of its security. You're not sure of its posture. You're not sure if it's got viruses on it or anything else. So you can limit where it could go. Or because of the device type itself, it might not be able to support the applications that maybe a full laptop could. So you can set policies based on whether you've got a tablet, whether you have a laptop, whether you have a smartphone, what resources that device is allowed to access. Then on top of that, everybody's always interested in a guest list ID. You could set guest rules up, and those guest rules could be, any guest will get access to the same resources, or once again, guest with a login, and based on what device type they are, you could set rules. Because with today's capabilities, I could look at the traffic a device is generating and say, this is a laptop, this is an iPhone, this is an iPad, this is an Android. That capability exists. It's available. So definitely take advantage of it, especially to control in a BYOD environment. Think about a school environment. You have students show up with all these tablets. A lot of your high-end tablets can act very close to a laptop and access all resources. But then you might have another student who's trying to access educational resources with a smartphone. and you can actually limit that or prevent that. This would be the other thing on block devices. You might say, if you have a smartphone, you're not getting on my Wi-Fi network. You could use the carrier side, the G3, the G4, the LTE capabilities, but you're not getting on my my corporate network. Or maybe they show up with a gaming device of some sort, or a media player of some sort. So based on what kind of device they have, you can set up different rules. So once again, that same individual with their own password with a laptop, they get full access. But with a smartphone or a tablet, you have none or limited access. This capability exists today, and you want to ask for it. So in summary, kind of wrapping this just up a little bit of what's happening in BYOD, the wireless devices are exploding. They absolutely are, and they're going to continue to grow and grow, and you just can't keep them off your network, so you need to find a better way to control them. Understand that iPads, tablets, smartphones will not give you the same capabilities. Understand the use cases. They will not give you the same capabilities of a full-blown laptop. They're going to be, you know, one quarter of the capabilities, of the bandwidth, of the performance of these other devices. You really need to understand that. To handle BYOD, to handle the density of devices, you really need to think about design, deploy, and manage. The whole idea is understand what devices you're going to allow on your network. Design it to support those devices. Deploy devices that can actually support it. Once again, the biggest thing you need to understand now is look at wireless devices that support what's called multi-state radios, that I can adjust to 2.4 or 5 gigahertz environments. I'm not locked into one or the other. And then manage it. Manage the devices, management the network, manage the users, and also, you know, visualize, monitor your environment, and at some point you go back to the whole design, deploy, manage phase again. So it's very cyclical, so you have to keep going through that. Our recommendations for BYOD, use 5 gigahertz. You have to focus on that as much as possible. Once again, there's nothing wrong with 2.4. We're going to continue to support it forever, but you just can't do high density, high performance in the 2.4 with hundreds and thousands of devices. It just isn't going to work. Make sure you design your network for a high enough signal level for tablets. If you're designing yourself, or if you're having a vendor come in, or you're having a consultant come in and say, I want to have Wi-Fi across my campus, across my building, across my environment, make sure you and them agree what that signal level is going to be. And if they're designing for -80 or -75 or -72 across that environment, it's not going to work. In order to support smartphones, in order to support tablets on your network, you have to design for -65, and you don't want to have to come back and do that later because that's a lot of new equipment, a lot of new cables to pull. So make sure everybody understands up front what these numbers are going to be. And these numbers, that what I'm saying, the -65 signal strength, has nothing to do with the Wi-Fi manufacturers. It has to do with device manufacturers, the people making the tablets, the people making the smartphones. That's what they're requiring, so make sure you design for it. In a high-performance environment, design for a max of 15 devices per radio. Sometimes it could be less. If I've got a classroom of students and they're all doing high-definition video, 15 on one radio could be too much or too many devices. So you need to understand what the use cases are. What are they trying to support? 15 users per device is probably going to give you a very reliable, very good connection. However, if I'm doing the cafeteria, maybe 50 users on a radio is good enough. Understand that. And understand the available tools to manage network devices, classrooms. Evaluate this, test it. If you're looking at multiple vendors, invite them all in and, you know, do a real-life test. Invite, you know, real-life experience. Every vendor out there can give you test cases where they shine. You know, if you're in a classroom environment or a school environment, invite 200 or 300 students into the cafeteria and set up a couple of Wi-Fi devices and see what actually happens. That's the only way you're really going to know what happens going forward. So that being said, that's kind of the market that we're in today. I want to spend a few minutes actually and talk about the XIRRUS solution, what we do, and then we'll take your questions as we go forward from here. XIRRUS does things a little bit different. I'll put my marketing hat on for a minute because obviously every vendor says that. But the XIRRUS Wi-Fi array is totally different than what most people have seen. It's really the industry's only modular wireless switch. And what I mean by that is instead of just deploying dozens or hundreds of thousands of 2-radio APs, we've gone beyond that. Yes, we can offer a 2-radio AP just like everybody else is, but that doesn't make sense to deploy 100 2-radio devices when I can just as easily deploy 20 4 or 8 radio devices and cover that exact same area and deploy it in 1/4 of the time with, you know, 1/4 of the number of cable pulls, 1/4 of the number of switch ports I need. So the whole idea is that you could purchase a array chassis that's either the one here is fully populated with 8 radios in it, or I could purchase it just with 4. And 2 weeks, 2 months, 2 years later, if I need more capacity, I can actually just upgrade that and basically take the top off, put some more radios in, and I'm done. No pulling cables, no adding switch ports. Or maybe I purchase it now with 300 megabit per second radios. Maybe next year I want to go to 450 megabit per second radios. Or the year after I want to go to 11 AC gigabit per radios. The whole idea is it becomes much more like a wired chassis solution that you install the device once, you pull the cables once, you connect it into your network once, and you just upgrade the capabilities as you go forward. On top of that, instead of using an omnidirectional antenna that propagates energy in all directions, we actually deploy a separate directional antenna in each one of our radios. What this does is a directional antenna propagates further. So a single device, like what you see up here, can typically cover a footprint of 4 traditional APs. Gives you a lot more capability. We had one school district down in Texas that was able to eliminate 4,000 APs basically by going to this design. That's 4,000 less devices to manage, 4,000 less cable runs, 4,000 less gigabit switch points. So obviously a much, much better solution. And we have no controller in the back end, so the intelligence is built into here. And if that's new to you, it's important just to think about this like you would a wired layer 2 or layer 3 switch. All the decisions are made at this point. So once again, you can deploy this one device by itself, or if you deploy, a few of them or dozens of them or hundreds of them, they'll communicate with each other and share information. The result is 75% less equipment, cable pulls, and switch ports. Very, very easy solution to deploy. Comparing a wired, and this is actually a classroom environment. No, actually, this was a convention center. The whole idea in this case, it was 80 APs versus 9 arrays. Once again, it's kind of a no-brainer as far as this. If they both give you the same capability, both give you the same resources. It doesn't make sense to pull all those other devices. Kind of give you an idea what the internal workings of it. On the left is an 8-chassis device, but only have 4 radios populated in it. I can just add the others as capacity needs grow. Very, very simple solution to do. Once again, you just take a few screws out, take the top off, and it gives you that flexibility. Once you go anywhere from 2 radios all the way up to 16, and our 2 radio, 4 radio, 8 radio, 12, 16 radio chassis, the radios are exactly the same, so you can mix and match them across the whole product line. So what the value proposition is modular. All the radios are multi-state, which means I can send them at 2.4 or 5 gig. Common components across everything. And it's the only product out there that's actually ready for the next generation of products. So whether you're going to purchase AC in the future or not, basically the whole idea is to understand that I can just pull the radio out. It takes about 3 seconds to bring it out. It snaps right back in and go to a totally different technology. Cover much more area with a single device. Cover far greater capacity with a single device. And cover far more devices with just a single access device. The bottom line is, fewer devices to install, fewer cables, no controller, low maintenance, no single point of failure. So once again, kind of a nice solution that XIRRUS offers across the whole product line. Once again, 2 to 16 modular APs. We have a complete network management system. That's the next thing people say. If you don't have a controller, how do you manage these devices? Well, you manage these devices just like you would manage a regular switched environment. You look at all of them, use SNMP, you gather information from here. Obviously, I can look at my devices. I can see their status. I can look at the heat map of the environment. I can look at the clients that are connected, what data rates they're connected at. I can set all my configurations up, and I can also manage the whole environment securely and look at all potential threats and actually deal with them just from one screen, one piece of glass, one management application. Very, very simple, easy way to deploy, easy way to see it. A couple of quick examples I'm going to look at. Obviously, Carnegie Mellon, a very well-known university, pretty much they eliminated 1,500 APs by going to this type of environment. Once again, very, very cost-effective for them, and obviously able to cover a large area with far fewer devices. And obviously, on higher ed space, you really need to be able to deal with the whole BYOD because you don't really have the ability to say no. You pretty much have to support whatever shows up. At the secondary primary level, Forsyth County is just north of Atlanta. Very interesting school district because they're going through a whole process of trying to figure out, how they're going to handle BYOD. For that area, Christmas was very, very good because they saw an 80% increase in devices from when students went home in December and when they came back in January this year. So they went from 10,000 BYOD student-owned devices to 18,000 over that period. What they're actually doing is they're looking at an environment to try to figure out what the devices they support. You know, in the secondary primary environment, a lot of school districts want to go to BYOD because it's cost effective. It's cost effective that I don't have to buy every student a laptop or a tablet or whatever. The problem is, and the challenge to the IT staff, is I can't support anything that shows up. I can't have a classroom with 30 students that have 20 different devices and 7 different operating systems and expect it to be effective during the day. You know you're going to have a tremendous amount of problems. So what the tools allow you to do is actually identify what type of devices are showing up on campus and then set some policies based on that. Say, okay, we're going to allow BYOD, but we can't allow everything. So what are the 3, the 4, the 5 different devices that I'm going to allow on campus? And once I set that, those are the recommendations that are going to go out to the parents. Those are what the students are going to have to bring in order to access the educational resources. And because you have to limit it. There's no way you can just allow anything to come in. You're going to have, you know, one person with a Kindle and somebody else with a $2,000 Hitachi, and, you know, they're not going to be able to do the same functionality. So you have to set some limits. But in addition to setting limits, you also can actually train your own staff. Is that these are the only 4 or 5 devices I'm supporting. Obviously, my staff can be educated far more on those 3 or 4 devices because you know you're going to have to support them at some level. As far as getting out of the education space, Salesforce.com is a recent event we did. Basically 4,200 people in one room at one time, all connected. You can do this. You can do this in a BYOD environment. You just have to be smart about it. You just can't plug everything in and hope it works. You have to look what's going on. You have to understand what's going on. You have to design for it. So, you know, 2 million square feet, 18,000 users, you can do it. You just need to be smart about it. And then also you've got the other type stuff. You got the Port of Houston's a good example. This was all outdoors. Basically, the wireless devices were going up on towers, basically light towers that cover, you know, a very, very large area and cover mobile users and back and forth. Wi-Fi can do this. Wi-Fi can do very, very high density. Wi-Fi can do very, very mobile. Wi-Fi can do very, very secure environments. You just have to design it correctly. You have to understand what's trying to be accomplished, understand the devices that are going to be connecting to it, understand the user expectations, and then you can be very, very successful with the Wi-Fi. So XIRRUS, kind of wrapping this up, you know, XIRRUS, we've been around since 2004. We're 100% focused on Wi-Fi. Our heritage is actually Xircom, so if you got a little bit more gray hair, you might remember Xircom was the first company that made adapter cards for your laptop, so you allowed you to connect it into the network and whatever. So we've actually been working with Wi-Fi before 802.11 was even standardized. So that's all we work on. We've been in business since 2004, very, very focused on just that one technology. Primary, obviously, we're involved in all the different verticals out there. The reason I mention this is the biggest challenge to Wi-Fi has always been, you know, does it give me enough performance? 11N gave you the performance. Does it give me reliability? Reliability is the design issue. You have to design it correctly. And does it give me security? If deployed correctly, Wi-Fi can be more secure than probably 80% of the wired networks out there. That being said, I think I'm gonna give it back to Matt now, and I think we'll take some questions.
Perfect. Thanks, Perry. This does bring it to the Q&A portion of our presentation today. Again, if you have any questions for our presenters, you can send those using the chat box on the lower right-hand side of your control panel. Let's get started with some questions that we've received. The first one I have here is, with no central controller, how do you configure all the APs?
Okay, I'll take that. Yeah, it's very, very simple. Most people think that you have to use a controller to configure the APs. You configure the APs with SNMP just like you would a wired switch. So I would have a management application, whether it's RxMS or a manager of managers that can import MIPS, and you'll go and set the configuration, and then you can push that configuration out to 1, 10, or 100 different access or what we call wireless arrays. Once again, it's very, very similar to the wireless environment. You don't actually need a controller to do that, even though most people think you do.
Very good, very good. Next question, what security features are available with the XIRRUS array?
Okay, that's the first or second question most people bring up about security. And with the array itself, obviously we have built-in all the authentication, all the standard authentication, all the standard encryption technologies available out there, WEP, WPA, WPA2, all the EAP standards, captive portal authentication, 802.1x functionality. But also because the array has intelligence built in, we're able actually to put a stateful firewall into the box, access control list into the box, IDS and IPS, intrusion detection service, that I can set one radio just to look basically for rogue APs and block those APs if required. So with the array product, you actually don't have to go and purchase a third-party security tool. It's all integrated into one platform.
Very good. Third question I've got here is, should I wait for 802.11ac to purchase a new solution?
Absolutely not. 11ac, once again, you're going to hear a lot of hype about it in the next probably Q3. You're going to start hearing more hype about it, read the trade magazines and all that stuff. But as far as a usable technology and upgradable technology, it's probably going to be the middle of next year, late next year, before you start really seeing it. Be aware that most clients today can't even take advantage of a 300 or 450 megabits per second 11N. So going to 11ac is more going to be a traditional upgrade. The 11ac is backwards compatible, so it's going to be a smooth transition, so I definitely wouldn't wait.
Got it. Good. All right, I've got a couple more questions here. The next one, how many other vendors do not use or require WLANs or WLAN controllers?
Actually, there's a couple. I'm not going to give any credit to our competitors right now, but there are a couple of other vendors that are actually have a distributed architecture like we do. What's more important is looking at the vendors that still do have controller-based architectures and the fact that their new generation of APs are taking on more and more responsibility rather than sending all the traffic back to the controller. Typically, most of your traffic for authentication, encryption purposes and stuff still needs to go back to the controller, but some of these new APs allow them to do local switching out at the edge, which some people call split MAC or dual MAC type functionalities. But pretty much all vendors know that because of the increase in density and the increase in performance of devices, you can't keep collapsing everything back into just a single controller, one or two controllers.
Very good. All right, due to time, I've got one last question here for you. We have a network and need to understand how it is going to support your BYOD initiative. Can you provide an assessment?
So Perry, I can take that question.
Okay.
Yes, for those who have existing networks or planning out a BYOD initiative or even looking to upgrade the network, through our engineers, we can help you use tools from XIRRUS to design and plan out the best possible network, as Perry mentioned. Really make sure that planning is as a key step in all of this process, and we can help you assist in finding the efficiency and the right number of arrays that will satisfy your requirements for the users as well as the devices that will be on your network.
Very good. Very good. Well, I want to thank you, Trevor and Perry, for another fantastic presentation. That concludes today's event. As you exit the webinar, please be sure to fill out the brief survey and give us your feedback. Thank you for attending, and have a great day.